Okay, so today's experiment we'll be working on is the molar volume of a gas. And we're going to be measuring the molar volume of carbon dioxide by using the known reaction of acetic acid and sodium bicarbonate, as well as the known reaction between acetic acid and sodium carbonate. By measuring the volume of gas collected, which we'll determine via water displacement, we will in turn be able to calculate the volume of carbon dioxide, and from the mass of sodium carbonate or sodium bicarbonate that we utilize in these reactions, we will be able to calculate the moles of carbon dioxide produced. Since we have the moles and the since we have the moles and the volume of carbon dioxide, we can in turn calculate the molar volume of carbon dioxide gas. Okay, so beginning in this experiment, you're going to need to have your 1-hole and 2-hole stoppers. So we're going to label the flask with the 1-hole stopper a 1. This is going to be our reaction flask. The flask with a 2-hole stopper will get a 2. This will be our water flask. Okay, now you're going to need to have the lubricating jelly when handling glassware. So you're going to get a pair of scissors out. And we're going to just cut open. And you're going to want to make sure that when you insert the glass into your stopper, that the glass is fully lubricated in order to prevent any breaking or any shattering events. So we're just going to gently coat. So we've coated our glass, our rigid glass tubing with the lubricating jelly. And now what we're going to do is we're going to get out our stopper. We're going to put the 3-inch tubing into the 1-hole stopper. Now the trick is that you want to use a gentle twisting motion. Do not push. You're just using torque. There we go. Gentle twisting motion. Do not push, or it will break and you could potentially injure your hand. Just a gentle twisting motion using torque. And now we have our first portion of this setup complete. And that's going to go snugly on Erlenmeyer flask 1. Now, for the next portion, we are going to insert a 3-inch and a 6-inch piece of tubing. So again, we're going to ensure that the tubing is fully lubricated before we try to insert it. So we're going to insert the 3-inch tubing. Again, gentle twisting motion, no pushing. Notice we're using torque. And again, if you feel any resistance, you're not to push, just twist with a gentle twisting motion. Okay, here we go. And now the tubing, the rigid glass tubing, that's the longest that will be going into our water solution, should be on the right-hand side. You want to make sure that this tubing is also lubricated with lubricating jelly. And again, just like before, we're going to very carefully, with a twisting motion, slide the tubing into our setup. And as you notice, one of the pieces of tubing will go further into our setup. Okay, so we have the first part done. If you happen to get any of the lubricating jelly on your gloves, you may want to clean your gloves and change your gloves just to make sure there are no issues. So, putting on our gloves once again. Now that we have the first part of this setup complete, we're going to prep our flexible tubing. We're going to prep our flexible tubing for this reaction. So first and foremost, we're going to take the flexible tubing that we had from our previous experiment. And we're going to take this flexible tubing and we're going to cut it in half. So we're going to break up this tubing into two discrete pieces. So let's cut this tubing in half. Okay, so now we have two pieces of tubing. Okay, the first of which we're going to use to link our setup in test tube 1. Just want to make sure that the tubing is on as snugly as possible. But remember, don't push too hard. You don't want to break any of the tubing. Okay, and now let's attach it to our second setup. And just to make things a little bit easier in this process, we can clamp down our setup as well. Next, what we're going to do is we're going to hook up our water collection flask. So to do that, we're just going to hook tubing from flask 2 into our graduated cylinder. So now that we have our entire setup prepared, whoops, sorry about that. So now that we have our entire setup prepared, let's just take a look at what our setup looks like. So we have flask 1 tubing connecting to flask 2, the 3-inch and the 6-inch rigid glass tubing, and then a piece of tubing going into our collecting graduated cylinder. Okay, so now that we have this first part all set up, now what we're going to do is we're going to continue on, and the barometric pressure of the room will be able to look up using the regional barometric pressure. Next, what we're going to do is we're going to weigh out the samples that we're going to be reacting in this experiment. So we're going to get out our balance, and we're going to weigh 1 gram of sodium bicarbonate as well as 1 gram of sodium carbonate. And we are going to react it with 25 milliliters of 4.5% acetic acid. So let's get out our balance for right now, and let's get out our weigh boats. So we get out our weigh boats and I'm going to label each of my weigh boats since we're going to need a total of 4 for this experiment. And you're more than welcome to write on the weigh boats. I like to do that just to keep things organized. So for my first set, I'm going to write sodium bicarbonate, NaHCO3. I'm going to label this as number 1. And number 2. So we have our 2 weigh boats for our bicarbonate, 1 and 2, 1 gram each. And we have our sodium carbonate weigh boats, which is Na2CO3, and I'm going to label them 1 and 2 as well. So here's our sodium carbonate weigh boat. It's important to keep things organized like this because you don't want to mix them up, because sodium carbonate and bicarbonate have slightly different stoichiometries with acetic acid. Okay, so now let's get out our spatula and let's weigh out 1 gram of material. So first and foremost, we're weighing out sodium bicarbonate. One moment. There we go. So let's weigh out our sodium bicarbonate. So let's find the sodium bicarbonate in our kit. So in the molar volume of gases kit, there are 2 bags, one of which is our sodium bicarbonate, shown here. So we're going to weigh out 1 gram of this bicarbonate. So let's turn on our balance. Let's place our weigh boat on the balance. Let's zero our weigh boat. So just for your reference, we can clearly see it's 0, 0. It's zeroed out. Yes, but we're going to record the exact mass that we weigh out. So let's now transfer 1 gram of sodium bicarbonate into our container. Okay. So just to verify that we have in fact weighed out 1 gram, here's our first 1 gram sample of sodium bicarbonate. Now let's weigh out our second sample of sodium bicarbonate. So I've zeroed and tared my balance. So now let's weigh out our remaining 1 gram of sodium bicarbonate. And since the bag is a 2 gram bag, you can be a little faster with this and just try to transfer and pour the remaining contents from your bag into your well, why is it giving 2 grams? It's a little too much. Okay, I guess the bag has way more than usual. So what we're going to do is we're going to transfer excess material back into our bag. So we only need 1 gram. Here we go. So let's seal up our bicarbonate bag. Clean off our spatula, and let's record the mass of our second run of sodium hydrogen carbonate. Okay, so as we can see, we have 1 gram. Let's repeat this process and weigh out 1 gram each of sodium carbonate. So let's place it on the balance. Let's tare. So now our weigh boat is reading 0, 0. And let's weigh out 1 gram of sodium carbonate found in your lab box kit. Remember, don't mix up carbonate and bicarbonate. They have very different reactivity. So I cleaned off my spatula, so now let's weigh out our sodium carbonate. Here we go. So as we can clearly see, for our first mass of sodium carbonate for trial 1, we have 1 gram of sodium carbonate. So we'll set that off to the side. And then for our second run, let's weigh out. So we've placed our weigh boat on the balance. Let's now tare our weigh boat. Okay, so now our sample is tared. Now let's weigh out our second 1 gram aliquot of sodium carbonate. And I find when you weigh all of your materials out at once, it saves you a lot of time in the long run. Okay, so we've transferred our second 1 gram portion of sodium carbonate. So this will be for trial 2. So we've weighed out 1 gram of all of our materials. Okay, so now we're ready to begin preparing our setup for this reaction. So we can put away our scale for now. Make sure to turn your scale off. Okay, so we can save our scale for now. In order to prepare your setup, what we're going to do is we're going to take this flask 2 and we're going to measure out 200 milliliters of distilled deionized water. So allow me to get some deionized water from my deionized water jug. Okay, so now what we're going to do is we're going to fill flask 2 with roughly 200 milliliters of distilled deionized water. Okay, perfect. And you want to make sure that your 6-inch tubing is clearly and very readily immersed into the water. Okay, so continuing on from there, we're now going to prepare and get set up our excess acetic acid. We're going to prepare our excess acetic acid for this reaction. So using our 100 milliliter graduated cylinder, we are going to dispense 25 milliliters of our 4.5% acetic acid, and we're going to place it into flask 1. So let's do that. So we'll get our 4.5% acetic acid from our lab box. Here we go. So let's now dispense 25 milliliters of our 4.5% acetic acid. One moment. I need to be able to see this at eye level to get it just right. Okay, so we have 25 milliliters of acetic acid that we will quickly pour into flask, Erlenmeyer flask 1. Now what we're going to do is we're going to clean and dry out our collection flask. So allow me one moment to do that. Let me get some more deionized water. Okay, so I've cleaned and dried my water collection flasks, my water collection graduated cylinder. And now we're almost ready to initiate the reaction. So just to give everyone a full view, so we have flask 1 that has our acetic acid, flask 2 that has our deionized water, and our graduated cylinder, which will be collecting the water displaced by our generated carbon dioxide in this reaction. So now that we want to initiate the reaction, first make sure flask 2 is very snug and secure. And all of your tubing, there aren't any leaks, or that they're all fully connected. And then what we're going to do is we're going to take our weigh boat of sodium bicarbonate or sodium hydrogen carbonate, and we are going to pour it into flask 1 and immediately cap it. So once you're ready to go, you're going to get ready and you're going to quickly pour and then put the cap on, and you'll immediately observe the generation of a large volume of gas from this reaction. So in order to further facilitate, you can continue to mix and stir your solutions. And you can continue to mix just to see if any additional reaction occurs and any additional liquid is generated. So at the end of this reaction, we've collected roughly 100 milliliters of liquid. Now, before we throw everything out, what we're going to do is we're just going to take the temperature. We're going to take apart our caps. And then what we're going to do is we're going to measure the temperature inside flask 2. So we'll let this sit for a little bit. We'll record the volume. So we've collected roughly 100 milliliters. It's not perfect because we're past the mark. We ended up with way more liquid displaced by our gas than expected. And this is for our first trial for 1 gram of sodium bicarbonate. So we collected roughly 100 milliliters. And then the temperature of the water in flask 2 was 17.8 degrees Celsius. We'll need this to calculate the vapor pressure of water. Okay, so now that we've collected our data, we've measured the volume of water displaced, we're going to completely clean all of our 3 containers, and then we're going to repeat this procedure. So let's clean our containers out, and let's put our waste in the waste container. And then we'll resume this experiment. And let's refill container 2. Okay, and now, just like before, we're going to clean and dry our Erlenmeyer flask, and then we're going to dispense another 25 milliliters of acetic acid. So let's dispense 25 milliliters of acetic acid into our Erlenmeyer flask. Let me just dry this off a little bit more. And let's dispense our excess acetic acid into our Erlenmeyer flask. So let's dispense 25 mils of acetic acid. So we have our .25 milliliters of acetic acid. And now let's pour that into flask 1. We're going to clean out this Erlenmeyer flask. Give me one moment to do that. And now what we're going to do is we're going to hook the tubing up. And we're going to make sure the tubing on flask 2 is secure. We're going to get out our second batch of sodium hydrogen carbonate. And we're going to very quickly transfer our sodium hydrogen carbonate into flask 1. So here's our complete setup. And we're going to quickly transfer our sodium hydrogen carbonate into flask 1 and record the volume of carbon dioxide produced. And in order to ensure that any of our excess, excess gas has been collected. Let's just agitate the solution. And it looks like the reaction has completed. Sometimes water is still left in the tubing before it's done. So, after unhooking the tubing, let's record the volume of water displaced. We have roughly 86 milliliters of water. And now, just like before, what we're going to do is we're going to take apart our setup. We're going to clean out our flasks, and we're going to repeat this process for the sodium carbonate sample. So allow me one moment to clean out all of the flasks, and now we'll look at the sodium carbonate next. Allow me one moment to clean and dry all of our flasks and to refill our Erlenmeyer flask 2. And for the temperature of the water should be the same between the trials. Okay, so let's hook up the following setup. Yeah, the second trial was 86 milliliters. The first trial was 100. And again, we're going to dispense and measure out 25 milliliters of acetic acid solution. You should have 2 acetic acid solutions in your lab kit. So let's dispense another 25 milliliters. Okay, so we have another 25 milliliters of acetic acid, and that's going to go into flask 1. Then we're going to clean out this Erlenmeyer flask. Give me one moment. Now that we've cleaned and dried out our Erlenmeyer flask, we're going to hook it up to our gas collection setup. And now what we're going to do is we're going to make sure the tubing in the second area is secure. And what we're going to do is we're going to very carefully, let me just move this over so it's all on the camera. We're going to very carefully transfer our sodium carbonate, our 1 gram of sodium carbonate, and we're going to observe the volume of gas collected. So let's begin, and let's very quickly, once you transfer it, you're going to cap it immediately. Here we go. So here's our sodium carbonate reaction. And this one you may have to mix. Notice how once I mixed it, the reaction really took off. So as we have a bit of an overflow, what we're going to do is we're going to transfer the excess very carefully to another beaker. And then what we're going to do as the reaction is finally finished, almost. So as it looks like our reaction's complete, we're going to measure the volume portion-wise. So first and foremost, we're going to pour out the excess. So our first volume collected was roughly 100 milliliters. So we'll dump this out. So we have 100 plus our excess volume collected. Which in this case, we have roughly 150 milliliters collected. So again, we're going to clean out the components in this setup, and then we'll repeat this procedure one more time. Note, if we had a better collection flask, this process would be a little easier to get a quantitative measure of the volume of carbon dioxide. Okay, so let's empty out our flasks and clean them for the next experiment. So we have one more trial. The temperature should be the same between trials, but we can take another temperature after this run. So now that we have our setup cleaned out, just like before, what we're going to do is we're going to measure out 25 milliliters of acetic acid. So let's do that. So we have our, oops, we need a little bit more. So we have our 25 milliliters of acetic acid, and we'll pour that in test tube 1. Erlenmeyer flask 1. Now we'll clean out this Erlenmeyer we'll clean out this graduated cylinder, and we'll react our acetic acid with our sodium carbonate. Okay, so let's hook this let's hook this graduated cylinder up to our Erlenmeyer flask. And let's very quickly initiate our second reaction with a 1 gram portion of sodium carbonate. Okay, so we've mixed our solutions. Now let's stir to initiate the reaction. So it looks like our reaction is almost done. Okay, it's finished bubbling, and we've collected roughly, 98 milliliters of water. For our second trial. Now, just for completeness sake, we're going to record the final temperature after our sodium carbonate reaction using our thermometer. And let's just check that. And we'll dispose of our remaining solution into our waste container. So our temperature at the end for our sodium carbonate reaction is 22.2 degrees Celsius. And we'll use that to calculate the vapor pressure of water in order to more accurately calculate the overall molar volume of carbon dioxide. So now we have all the information we need to complete the calculations for today's laboratory, which is the molar volume of carbon dioxide. I wouldn't expect super accurate data considering we're using a graduated cylinder to measure the volume of water displaced rather than a eudometer. It probably would be better if we used a smaller scale rather than the scale, a smaller amount of each reagent compared to the amount recommended in the lab manual. But we certainly have enough data to go through the calculations and showcase how to calculate the molar volume of carbon dioxide for each of these 4 trials. So we'll discuss that in our lab lecture.